Ready? I want to get an idea of what's in there, and I don't want to pick one at a time. To make life easy, I'm going to start with 10. Yeah? Here's 10. 4, 5, 6, 7, 8. Oops! 5, 6, 8, 9, 10. Now what's going to happen now? I picked 10. Would 10 be very reliable? Say the obvious. Nah. With 20? When I first did this, we did lots of 20. And it made me look like a total moron with my probabilities because it all went stupid. Because 20 is not very reliable. So we're going to do 50. I'd really rather do 100. But time's a problem. And there's only so many beads. I wish I should have bought another 10 packets and had a really big tub full. Give you a better idea.
We could each do 10.
Yeah, you each do. We're not going to do 10s. How are we going for time? We're okay. Now, let's have a look at what we're talking about. How many pink? 1, 2, 3, 4, 5, 6, 7. It's not bad. It didn't make a weirdo one. Could I have picked 10? Don't do that. Is it more likely I'm going to pick 10 pink or 10 blue? 10 pink. So you guys who really don't get probability, time to take it in. So it's more likely to get pink. So you're more likely to get 10 or 9 pink than you are to get 10 or 9 blue. So we talk about this now as a P, and this time the P is how many? 7 out of 10. But it's actually what we call a sample. When you go out and get a sample, we don't know the real figure, because we don't know what it is. I don't know what it is. I know it's somewhere about 0.6 or 0.7. We call it P hat. And from here on, our proportion will have a hat on it. So if you walked out and you did a survey and you wanted to know who liked spaghetti bog again, and you got 10 kids, and you went out and get 10, and you went out and got 10, and you went out and get 10, you might come out back with 10, you might come back with 9, you might come back with 6, you might come back with 2, and it's natural variety. It happens all the time. So then we can do with that as 0.7. So let's look at the mean. What's the mean? NP, just like before. But we're doing it in lots of 10. So we're going to divide it by how many we did. So let's have a look what happens. N is 10. This is what mucks people's brain up. And I keep thinking, how do I explain it? And we had 0.7, didn't we? If we divide it by 10, what do we end up with?
Doesn't that equal just P?
Yes. Now that's not the important one. That's the important one to help you with the next thing. Why did we divide by N? End up with just P. So guess what we do next? Standard deviation. And this mucks people's brains up. What are we after now? Standard deviation for that group of 10 that I picked out. Formula is same as before. NPQ. You know how we divided this by 10? Which is N. How do you divide that one by N? Major thing of stats. Now watch what happens. I'm going to do it two ways. So what's the questions from home? Hanging with the questions. We had a 10. We had a point what? 7. Because this is the only thing we know. Doesn't mean 0.7's true. We know it's not true. But it's a good estimate. Looks like pretty good. That looks like 0.7. Yeah? What would I do if I wanted a better estimate? Pick out 100. 200. 500. So 0.7 by 0.3. I'm going to divide that all by how much? 10. So decimals again. 7 3s are 21 times by 10. Slow down. 210. How many decimals in the question? Yeah? And then we're going to divide that by 10. You put in your calculator and find it out. I think by heart that's 1.449. And divide it by 10. No one writes a formula like that. They write it like this. NPQ, just like that. But they divide by N on the inside. How do I put a number, like say I put 3 on the inside. 3 is the square root of 9. 4 is the square root of 16. 10 is the square root of 100. N is the square root of N squared. One of those N cancel with one of those N. So if you go out and do a sample of 50 people, what do we write? Here's the formula. I didn't do a sample of 50. How do I do a sample of? 10. So I don't write N there. P is 0.7. So that means Q is 0.3, and you're going to do this over and over and over and over. Okay? Divided by how many? 10. So what have we got now? I nearly lost the B. 7 3s are 21.21. You're okay if I do that quick now, divide by 10. What happens when you divide by 10? The decimal moves one place, which way? So that's actually the square root of 0.021. If you put that in your calculator, they both come out with 0.0944, I think. I'd have to look that up and see what it is. What happens if I, instead of 10, I picked 100? So if I've got 0.7, it'll still be, say I picked 100 and I got 70. That's still 0.7. That's still 0.3, and that becomes a 100. This is called the standard deviation. 100's more reliable than 10. What do they really use? If I watch American TV and they're talking about the elections, I was watching some recently. I find it fascinating. It tells me a lot of stuff of what's happening around the world. They do surveys of about 1,000. Okay? So that would be 100. 0.21 divided by 100 would be not 0.021. What is it? 0.0021. That's become smaller. And what's that thing called? Standard deviation. So if the standard deviation on a bell curve becomes smaller, you're right, standard deviation becomes larger, area under the curve still has to be how much? 1. So what's happening as you get, if we had 10 that's out here, if we had 100 it comes right back into here, becoming more what? I use the word reliable. How about I say less variety? If you picked out 100, if I got Elijah to pick out 100, and he said, Mr. P, I got 95 pick. You could see my reaction, maybe. You got what? Mr. P, I didn't cheat. I got no, Elijah, you were going, oh look, I got a pink. Oh look, I randomly got another pink. Get the idea? Yes? Real life though, you go out there and you interview 100 people and you say, do they like the Prime Minister? And you happen to be at of course, a stupid case is you're at a conference for his people. And 95 of them say, yes, we like him. Yeah? But if you go out and random, then you'd instantly say that wasn't reliable because it was biased. Why was it biased? And the big word is it wasn't R-A-N-D. Wasn't random. It was dumb. Thank you. It was dumb. But you can't say in the ways it was dumb. You can say it and we'll have a laugh. And then, year 12 assessment, we'd have a laugh. So it's not random. Now watch. This is the moment of truth. I really like this. You're going to be impressed with it. How many are there? Count to 50. Is it random if I do it is it random enough if I do it like that and I shake a few off? Now, don't look at the last ones when you're trying to figure out 50. So, that's your lot. And it's quite interesting how often people fluke 50. Can you reach that there? So can you go out and level it out and put yourself out of the bunch? So we're doing in groups of, we're counting and surveying in groups of 50. I would rather survey in groups of.
It doesn't look like 50 in each part.
Isn't it pretty scary? Wait to see what they say.
So what do we do if we don't get 50?
Then grab some more.
Then
If
you
you're more
trash.
than 50, chuck them back in.
Okay.
But don't look at it and go, oh, I'm going to chuck all the pinks back in.
I got a restart.
I count them in lots of 5, by the way.
48.
48, look at that. Is that good or is that?
It's great.
It's great. Thank you. You go to the top of the class. And as you get your numbers, I'm going to record them on my trusty little sheet. This looks like that. And then tell me how many pink you got out of 50 though.
Yeah.
Now, is this, give me a sec, is this perfect? No.
No. 53.
53, so you randomly pick out 3 and put them in the tub. You can't look at what's,
We do the excess one.
Can you do it fairly?
put them back in the tub.
Oh, right.
Okay, we're not going to record the pink, we're going to record the blue.
I don't know
I
if
got
this
15.
one's mine.
So we're talking about blue, okay? 16. So that'll be 16 out of 50, that's there. I'll get one of them. Anyone else got theirs?
I got 15.
15
Oh, that's
out of 50, that goes there.
Could I have the?
Yes.
Yeah, you gotta
Oh.
really count your bees.
That's all a plan.
That was the plan.
By the way, we know it's about, look, I know it's about a third. And so far, most results are about close to a third. These are the results of what we did in class with all that chaos. We ended up with 49 samples that we took in the group. I went away myself and did another 41, taking it up to 90 actual samples or surveys. Interesting part is one of the boys got 26 out of 50, and I was joking that it was an outlier and that it's pretty crazy. And then doing it myself, I ended up getting a 28 out of 50, which was pretty out there. I didn't expect that. Interesting part, if you look at the final figures up there, calculated the mean for this group was 17.21, which was really impressive because the actual data would be about 17.33. So the mean of the samples that we did ended up being extremely close, and a standard deviation of 3.6. Pretty impressive with the whole process. There's all the careless things that happen and the mucking around, but it still works out surprisingly well. So the central limit theorem says as n increases, the distribution of the samples will approach a normal distribution or a bell curve. So in previous years I did it with groups of 20. You could still see it would make towards a bell curve, but it wasn't great. So I started doing 50. So these are lots of 50. I'd like to do it as 100 one day, but I don't know if that'll ever happen. But with lots of 50, it roughly approaches a bell curve. Interestingly, the overall figures are better in terms of estimating the actual proportion of blue beads are in the group, which was about a third. Worked out quite well as the average of the samples that we took. Now the rest of the video from here on, there's a lot of just mucking around for the sake of my year 12s that can have a look at it and have a laugh at what happened. It was quite enjoyable, load of fun. I think I might have had more fun than the students.
I'm only 6 off this time.
Oh good, 6 too many?
Yeah.
Yeah. So now you're going to adjust your scientific method, and your challenge is the next time get 50. What's the chance you're getting 50?
Pretty low.
Exactly.
Yeah, let me get a scoop. I'll get a scoop and you guys can count it.
Yeah.
POV, you're getting
Yeah.
a scoop.
I got
Some-
50.
Cameraman's coming in.
23. You got a big one.
Jeez, no, the holes.
Stop the cap.
Alright.
There you go for it. So you
Is
need,
it? Am I couch counting the blues?
you need to count all of them, make sure you got 50.
You count them.
Yeah, that's good job. You're the cameraman.
I'm the cameraman. I can't count and hold.
POV, you're counting.
I keep counting different.
How to
Oh
contain
no, annoying. How many?
20.
How many?
17.
17
That's 3 less than me.
and a 20.
20, yeah.
No one's got an 18 and 19 yet.
10.
Now talk to you for a second about if this was real and we were going out doing 50 and we were going to Mundaring and you know, like there's only a limited population anyway. You come up to someone, they say, I already did it yesterday. Yeah?
Yeah.
So everything
I
about
got
it.
18 blue.
18, the first 18.
Where's the
I got 17.
17.
I got 13.
Got 13, the first, no, I got 13. I got 12, we got a 12.
That's right.
Hey!
Are we making a bell curve with this?
Hey?
Are we making a bell
Yeah,
curve?
yeah. That's called the Central Limit Theorem. As n increases, you form a bell curve. Now, which had to increase though? We're doing 50s. So if we had n with 100, or better still, we had n with 1,000.
20.
20.
Oh, wait,
10. 10!
I am.
Yeah.
He got a 10!
Oh, 10.
Okay, that's actually.
That's pretty sus.
How is it sus?
Well, we can work out the probability of anything.
He's gonna cut this out anyway.
I just oh no. Why is that?
Yeah, actually. Yeah, let me get my raid in.
14, 15.
Yeah, I'll hold the raid. You hold the camera.
What's the
11.
probability of getting a
That's
good
more
base
like
on
it.
the next one?
Because it was more.
One.
Very low.
It's 1.
That's good enough.
Yeah, that'll do.
What are you doing?
Very nice.
We're getting a raid in on the video.
We had 29 blue ones.
What am I counting?
Alright, take out the air defense.
Mm-hmm.
come on, come on.
Yeah.
22.
This side's basically completely open, but we're going to want to take out the other air defense first. Dragons are still going. Math still being done.
70% overall
Just
damage.
get in there.
Liam, what are you doing? Count!
He's watching my magic.
I've retired. He's watching your. I'm not gonna say that.
Yeah, don't. I
What
wouldn't.
are you doing?
Quick. Hey, come on, another 3 minutes. Come on, go. You beat it out.
I can't count anymore.
This is probably the most people he's ever had to do this, and we've done the most.
It is
And we've done the
true.
most.
We should have been counting out 100.
See my time?
50 divided by 2.
Yeah,
Let's
26.
exclude that one.
What? Why
It's
are
an
you
outlier. We
How
don't
many you
trust
say?
it.
20?
26.
No, exclude it.
What is an exclusion? That
Because-
helps.
I
That's
don't
a
Possible.
trust
That's a helpfulness. It's possible to get 50.
Now, by the way, you can get your standard deviations. Can you imagine one standard deviation, two, come on,
Well, which one's
3 standard deviation? In the middle there somewhere. How do I calculate it?
Wait, say that again. How do you
Oh,
calculate?
count like the mean. So
I got it.
0.2 by 1,
20.
20, 20.
Can I
I go 0.2 by 1, 0.22 by 1, 0.24 by 1, 0.26 by 7, 0.28 by 3. Put in my calculator. And list 1 will have 0.2, 0.22, put those. And list 2 will have the frequency. And I go bing and I get the actual mean and the actual standard deviation. Which will give us an idea of how many really were there. And then I can do first, second, third standard deviation. And I can officially say that's an outlier by the statistics.
You're an outlier, Colin.
Yeah.
I'm elite.
You're right, we're going to leave everything the way it is.
Where's the cat?
Done, get the point. We need more.
Boom, that's a wrap. That's a representation of semester 2 exam score. That's me right up there.
That's me.
That's you.
Yeah, well,
But that was also me.
the highest scores are on the left, the lowest are on the right.
Yeah, that's
Yeah,
it.
was that 10? Yeah, that
Have a good
only 10 was
weekend. Leave these where they are. Go home.